Good morning. My name is Ashutosh Garg. I work as a solution provider with Furnace Improvements. In March this year, our company completed 25 years in business in the US. Furnace Improvements is conducting free fire heater training webinars this year as a part of our Silver Jubilee celebrations. Welcome to today's training session on ethylene cracking furnaces. I welcome you all. We have received more than 50 registrations today, and we thank all of you for your time and interest. So first, why are we talking about ethylene cracking furnaces? We don't build ethylene crackers. We can help you improve the performance of your cracking furnaces. All furnaces are the same. Ethylene cracking, the only difference is it has a radiant coil where the reaction is taking place. It is a very high temperature furnace. Other than that, the furnace, like any other furnace, has a radiant section, convection section, burner, stack, waste heat recovery, ID fan. They are all designed and built to the same standard. So we think we can help you improve the run length and coil life of your furnaces. Today, we will talk briefly about our coking index and our inclined firing that can be used in your furnaces. We will have the interactive presentation for 90 minutes. Please keep on sending your questions on the GoToWebinar platform. We had done the session 1 in May this year. All the previous webinars are available on our YouTube channel. So let me start the Kahoot. We will be conducting this webinar through Kahoot. It's a game-based learning platform that makes learning awesome. I discovered this platform while I was playing a trivia with a bunch of my friends. And I was so impressed by the platform that I decided to do all our webinars using this interactive platform. I think it's a thing which is interactive. I mean, I have been doing training for almost 25 years. And most of the training which I have done in the past, whether it was for engineers or whether it was for operators, was mostly a one-way transaction. I would get some feedback during the engineers class, but most of the time it was one-way traffic. So what I find this platform to be different is that you can interact, and interact is the key. We are talking about two-way street, back and forth. And that's what I appreciate or admire about this platform. So, and this is completely secure. I think it is used by more than 400 of the biggest corporations in US, including Microsoft, Google, and Apple. So it's a very secure platform. Your identity is completely anonymous, and you will really enjoy this game. So as I said, this is basically for two-way platform. That's what we will do. The pin is 1576463. If you have not registered, again, I request you to register. And you can go to www.kahoot.it or download the app on your phone. It's both available both on Apple and Android platforms. So I've always started my training sessions with a brief introduction of myself, even though I think sometimes I don't even need an introduction. I'm a chemical engineer. I've been working on furnaces for almost more than 45 years. I passed out of IIT Kanpur in 1974. And since 1976, I've been working on fired heaters and combustion systems. I've worked in KT India, Engineers India, and KTI Corporation in US. I've been working on with furnace improvement since 1996. We work on revamping fired heaters and improving this thing. This presentation today, my team has worked very hard. I'm only the face, the front face, but it is my team members, Sushil, Meghna, Deepika, and all the process people who have been working hard on all these webinars. And they basically, including the designers and 3D people who develop all these sketches. So I want to thank all my team members who have contributed to the webinar. So furnace improvements pays our bills. So I have to give you a little bit commercial or web infomercial on furnace improvements. Let me tell you a story how I started furnace improvements. It was 1994 or so. I was taking a tour of Baytown and Texas City here in Houston with a sales engineer from KTI. And I just asked Bob, I said, Bob, there are furnaces all around. Who takes care of these furnaces? He said, nobody. And I said, why? He said, fixing furnaces is a dirty business. All furnace vendors, they want to work on new heaters. So our focus has always been working on new heaters. So as luck would have it, there was an opportunity in 1996. I got laid off, not exactly laid off, but I got an opportunity in 1996 to start. And I said, why don't I take up this challenge of working with old furnaces, fixing old furnaces? And that's what we have been doing since 1996. It's been almost 25 years. And we have been very lucky. I mean, our clients have been extremely gracious, I would say, and have promoted us, have given us a lot of business. So today we have 3 offices. Our main office is in Noida, India. We opened it in 2005, and that's where all the engineering talent resides, actually. The Sugarland office, which used to be a big office, is now a project office or sales office. It only has 5 people. And then we opened a CFD office in Pune in 2014 because we found CFD is a very powerful tool. And we can demonstrate to the clients if CFD is done correctly, the value of our improvements. We can show it to you how inclined firing or whatever we are proposing on burners or heaters, you can see it. So that's typically what we focus on, what we have been working. We provide unique solutions. So one of the things I want to tell you is We have a contrarian approach. We always challenge the things the way they have been done. We say, why not do it differently? And that has been our motivation all these 25 years. Why not do something new? Why not? And we have been very successful. We have 3 patents. We have split flow, we have inclined firing, we have smart damper. So we have been trying to resolve problems. We take pride in doing high quality technical work. My team is very, very good. They do all this. Because of time difference, we practically can work around the schedule, around the clock. And we keep schedules. Our philosophy is do it once, do it right. I want to tell you a story. There was a refinery in Latin America, Suriname. I don't know how many of you have heard of Suriname. It is a Dutch colony, and they even have a refinery, and they were upgrading their refinery. They wanted to buy, they bought 9 heaters, but in reality, they ordered only 8 heaters, and they forgot the ninth heater. And later on, they went through whole of USA. They contacted all the people, heater vendors, and nobody could supply them a heater in 4 months. We took up the challenge and we made sure that heater is on the ship within 4 months. That is how fast our team works. It's because we are focused, we are small, we can perform. So let's talk about, we plan to do 4 sessions on ethylene crackers. This is our second session. We organize the first session in May. They are at 3 months interval. If you have missed my first session, you can see it on GoToWebinar or on our YouTube channel. We talked about basic introduction, talked about nomenclature, fuels and combustion, and reaction kinetics. That's what we talked about in our first session. So today we will talk about radiant section, which is the main section in any furnace. We'll talk about how it is designed, what are the main components, talk a little bit about coil metallurgy and transfer line exchangers. Then we will move to convection section. And then finally, stack, draft, and ID fan. That's what we will be covering today. So let's talk about a little bit about ethylene cracking furnace. As I said in the beginning, there are 3 types of heaters. The first type of heater is the simplest heater, which is called a gas heater or a liquid heater, whereas the liquid goes in, liquid comes out, or gas goes in, gas comes out. The second type of heater is where a phase change occurs. That means liquid comes in, but liquid plus gas goes out. They are very common in refineries. We are talking of crude, we are talking of vacuum, cokers, all these type of things. The third type of heater is where a reaction is taking place. That means whatever is going inside is not the same what comes out. And these are called reaction heaters. You can call coker as a mild reaction heater because it's a coke which comes out of the coker heater. Other 3 heaters basically are EDC cracking heaters, which are used for manufacture of PVC. We talk about steam methane reformers for making hydrogen, making ammonia, making methanol. That's another reaction heater. And then the ethylene crackers. So these are called as tubular heaters, tubular reactors. In all these cases, we are talking of endothermic reactions. We're talking of endothermic reactions, and we have to supply heat, and that is why we use a furnace to supply that heat. What we do, we take the feed, we preheat, we preheat in the convection section, then we add dilution steam, and then again we preheat in the convection section. If we have a gaseous feed, then we are only talking of sensible energy. And if we have a liquid feed, then we also need latent heat. We'll talk about energy conservation, but one of the differences I find between a refinery and a petrochemical plant is petrochemical business is very competitive. It is so competitive that people are talking about maybe 99%, or whether you can get it or not, but they are talking of 95, 96, 97% efficiency improvement, efficiency of the furnace. And at the same time, I see refinery furnaces, they are both side by side. But the refinery furnaces are working on 60%, 70%, 75% efficiency. And it's happening side by side in the same country, but that's basically the nature of business. So I think it is good in the sense that we are talking of greenhouse gases, carbon-free world, and the more efficiency we talk about, the less emissions we will have. And my thinking is all these furnaces will see a lot of change in the next 20, 25 years. I'm not even sure how many furnaces will even survive. But maybe they all they all start firing hydrogen actually. I don't know. I'm just thinking, maybe they will start firing hydrogen. They are already, has been in the news for NOx emissions for the last 25 years, and now maybe it's a greenhouse gases, what we will talk about. So this sketch shows a principal arrangement of cracking furnace. We're talking of a radiant section, convection section, transfer line exchangers, and ID fan on the top, stack and ID fan in the top. No matter whose furnace you got, whether you got Lummus furnace or whether you got Kellogg furnace or you got Technip or you got Stone Webster, Linde, radiant section more or less remains the same. Maybe the coil is different, but other than that, the radiant section remains the same. The convection section is mostly very similar. Transfer line exchangers are different based on the different licensors, and then the stack and ID fan is still the same actually. So the principal arrangement is mostly the same in all these furnaces. It's showing different services in the convection section. So in the radiant section, that's where heat transfer by radiation is taking place. Almost 80 to 90% of the heat transfer which takes place in the radiation section is by radiant. Say about 10% is by convection. Also, most of the tube failures which occur in cracking furnaces is in the radiant section due to high tube metal temperature, carburization, and all those type of things. So we feel optimum design of radiant section is very, very important. So we'll talk about the radiant section. What should be radiant section doing? We are talking of uniform heat distribution. We want to have no flame impingement, and we want to have complete combustion. Just give me a minute. Let me put the light on. So that's what we are talking of. Now, the thing about ethylene cracking furnaces is it runs so hot that it is almost impossible to see flame impingement. The flames, you really can't even see the flame. So it becomes a big challenge. And we will talk about complete combustion. So that's what we want to talk about. So one important parameter in the radiant section is radiant heat flux density. And it's basically heat duty per unit area. Now in cracking furnaces, what has been happening is, if you see the history of 50 years, how the cracking furnaces have evolved, most of the developments which have taken place due to improvement in the tube metallurgy. The metallurgists have worked very hard, and they have come out with exotic alloys which can allow us to go to almost like 2000 degree F2 metal temperatures or 2100 degree F2 metal temperatures. And as a result, we are talking of very short residence time furnaces. And when we talk of short residence time furnaces, that means we have to heat them in about 0.1 second or maybe 0.2 second, 0.3 second. So as a result, the surface, what we need, the heat transfer surface becomes very small because you want to heat it very fast. And as a result, the flux has gone up from maybe 10 or 12,000 50 years ago to today about 30,000. And when we do that 30,000, that means we are providing only 1/3 the surface area. The radiant section itself, the size has come down. So the furnaces have become very compact. And as a result, the size of furnaces have gone up substantially. That's what has happened. So the limitation is tube metal temperature, coking, and run length. So these are some of the issues with the. All right, so we do have a quiz for you, and this is how much heat is transferred by the radiant section in ethylene furnace. So if I want to tell you, if you look at the refinery furnaces, okay, the correct answer is 38 to 40, 50%. I think the number hovers around 40 to 44%. That's where. If you look at the refinery furnaces, we transfer almost 70% heat in the radiant section. In fact, if you have a air preheater, then the radiant section heat absorption goes up by even another 5%. So the heat transfer could be anywhere around 75%. And the convection section is about 25 to 30%. This is one of the few furnaces where convection section is absorbing more heat than the radiant section. Convection section absorbs almost 50-55% of the heat, as compared to radiation. And that is because of the change that our boxes have become very, very high temperature. So, well, thank you for participating. Let's move on to next one. So as I said, the radiant section absorbs, I would say, around 45%, and convection section absorbs 55%. And a lot of times you will see the size of convection section is much bigger than the radiant section. The height of the convection sections, you will see, as you can see over here in this sketch, the height of the convection section is much taller than the radiant section. Can happen because we are trying to extract the last BTU or last kilocalorie from the radiant section, from the fuel gases. So let us talk about how does the radiant heat transfer takes place. And if you see, this is the configuration, double row single fired, and all the heaters, when they started building heaters in 1930s, they were built like that, double row. And then they found out that the back row is not able to absorb a lot of heat. In fact, it was only 15%. The front row would absorb 85%, and the back row will absorb only 15%. So they started removing the back row. And most of the furnaces, they graduated from here to here, single row, single fired. That's what they started doing. And then they came to this design, which is double row, double fired. And this is almost similar to the one which I showed you, single fired, but basically still gives you, and it does have a flexibility of adjusting the pitch over here. So that's basically what you see over here. And in fact, there are some furnace vendors, cracking vendors who have started revamping the existing radiation section or existing furnaces with this type of arrangement. That's another reason why I'm trying to show you over here, is to, from this conventional single row, they have gone to double row. So, and they are able to get more capacity or more, out of these coils by going with this design. This is another design which is very, very common. Most of the furnaces are built like that. This is single row double fired. That means tube is fired from both the sides. And what is the benefit of firing it from both the sides is that the firing is very uniform. That means the maximum flux compared to the average flux, that ratio is only 1.2. Whereas if you look at this design, the ratio of maximum flux to average flux is about 1.8. So you can see we can either go for a higher flux in that, or we can go for this design. Now, I do want to tell you that two things have happened. One is everything used to be horizontal. All the tubes used to be horizontal tubes, and I think around 1960s, we started changing from horizontal to vertical. That is another change which has happened in the most of the furnaces, and it happened in the cracking furnaces also. The another change which has happened is in the early days, all these heaters, cracking heaters, used to be side fired. There used to be 6 or 7 rows of burners, and these burners would be called radiant wall burners. The burner flames were impinging on the radiant wall, and from wall it was radiating heat. And that was the common design for almost, I would say, up to 1980s or maybe even 1990s. I think in 1990 they started changing to floor firing. And what they did was they took out the bottom 4 rows and put burners at the bottom. And that's what they did. And I think my guess is 20 years ago, they did away with the side firing completely. And I believe all the vendors are going with the floor burners. Now, there are so many reasons why they did that. I think they found with the side firing, the heat distribution arrangement was not, even though it was supposed to be uniform, but in practice it was not there. The other thing which happened is low NOx burners, ultra low NOx burners, and the third thing is firing of high hydrogen gases. Hydrogen gases are not particularly useful in premix burners. They have a lot more chance of flashback in these burners. So that, I think those were some of the reasons why the industry changed from side wall firing to floor firing. Okay, let's move on. I